Hi guys, how you doing? It's me again. Welcome to Enzo's sharing time, and let's crack chemistry together. Please subscribe my channel and turn on the notifications so you can watch my video as soon as they are posted. Also, do not forget to leave your comments below and like my video. Last time we walked through section 1.2, the atomic world. There are 4 main points to keep in mind. Number 1 is atoms are the basic units of substances, and they form elements and compounds. Do you still remember differences between them? The second point is atoms can exist in various forms, like monatomic, molecules, giant molecules, which is also called lattice network, etc. Next, we learned how to use chemical symbols denoting elements. Rules are simple, but ladies and gentlemen, may I have your attention now? Please do ensure you make it right, because this is the foundation of chemistry. The last point is periodic table. Can you tell me how many periods and groups there are in one periodic table? 7 periods and 18 groups. Another thing is groups can have their own names, such as halogen group or noble gases. If you forget the above details, then I strongly recommend reviewing my last video. Now let's move on to today's topic, section 1.3, inside atoms. In this section, I will show you the subatomic structures and how they are related to each other. We'll cover 5 points and test your understanding with 3 exercise questions. The first point is atoms composition. Generally speaking, an atom is the sum of a nucleus plus a cloud of electrons. The nucleus is positively charged, while the cloud of electrons is negatively charged. Let's take a close look at an atom model. Here, we can see clearly that the large dotted circle denotes the boundary of an atom, while most space within the boundary is occupied by a cloud of electrons. And nucleus, which is the core of an atom, locates in the center, occupying only a trifle of space. Well, as to electrons, they can be written as lowercase e, just as what it shows here. From this, we can see that the cloud of electrons are much larger than the nucleus, and also it surrounds the nucleus. In this picture, all the space within this atom but outside the nucleus belongs to the cloud of electrons, and electrons can be anywhere within it. Compared to the cloud of electrons, the nucleus is quite small in size, while it consists of 2 kinds of subatomic particles, protons and neutrons. Neutrons can be denoted by lowercase n, and why they are called neutrons is because they do not carry charges, being electrically neutral. Like what this picture shows, inside the nucleus we use lovely red spheres denoting neutrons, and do you know what are the yellow balls? They're protons, which can also be written by lowercase p, and they carry positive charges. So now, do you know who contributes to positive charges of a nucleus? Alright. Regarding to the second point, let's discuss the size and mass of a particle like nucleus, protons, and neutrons. Like we mentioned, a nucleus only occupies a trifle of space inside atoms. But specifically, how small is it? By way of analogy, if we use a P to represent a nucleus, then an atom could be represented by a soccer court, which means the latter is 10 gram to 100 gram times larger than the former. But as to mass, they are almost equal. In fact, a nucleus may contribute to 99.97% of an atom's mass. Now let's focus on the comparison between protons and neutrons. They have a common name, nucleons. These 2 kinds of particles are of similar size and mass, and they are rather huge to an electron. Look at the 2 similar balls on this scale. They denote protons and neutrons respectively, and you can easily remember this point by thinking of this scale. The next point is about electrons. Although a cloud of electrons is 10 gram to 100 gram times larger than a nucleus. For one single electron, its size and mass are both 1800 times smaller than those of a proton or a neutron. This is like the width of a hair compared to the diameter of a melon. So we will have an extremely imbalanced scale here if we weigh them together. Now it's time to review what electron cloud is. In fact, it is an abstract concept used by scientists to denote possible distribution of electrons. As this picture shows, in this atom there are only 4 electrons. You can count them one by one, and finally you will get to know that there are only 4 of electrons here. And actually they run pretty fast towards random directions, while still surrounding the nucleus. In order to get an idea where they're most or least likely to appear, let's imagine we take a lot of photos of them. And when combining these photos together, we will have a single picture showing millions of electrons. They look like a cloud with dense areas where the electrons are more likely to appear, and also with sparse areas where electrons are less likely to appear. The size of electron cloud is almost the same as an atom, which is 10 gram to 100 gram times larger than a nucleus, considering a nucleus only occupies negligible space. The second last point is electrostatic attraction. Just as what this name tells us, it is the attraction between positively and negatively charged particles. For example, one electron carries one negative charge and one proton carries one positive charge. They carry the same amount but opposite charges. Because of this, a nucleus can keep its own electrons, confining them within this atom. Now I will have a question for you. Why an atom carries 0 net charges? Because ultimately, the charges from protons and electrons cancel out, which means the number of electrons and protons must be the same for an atom. Please keep this finding in mind, as we will make a good use of it in future. Last point of today is an overall comparison of particle size, mass, and charges. Here I list all of the particles in today's lecture. I assume the mass of an atom is capital M. Then, from the lightest to the heaviest, if the mass of an electron is lowercase m, then the mass of electron cloud is number of electrons times lowercase m, contributing to 0.03% of the mass of an atom, which is negligible. As to protons and neutrons, their respective mass is 1800 lowercase m. And the mass of nucleus equals to total number of electrons and neutrons times 1800 lowercase m. And this mass also contributes 99.97% to capital M, which is the mass of an atom. Okay, the next is size. If we assume the size of an electron is 1 unit, then that of a proton or neutron is 1800 units, just as what it shows here. While the diameter of a nucleus remains uncertain unless we know what atom we are discussing. But let's just use X to represent it. Of course, X is larger than 1800 units, and then the size of electron cloud as well as atom will be 10 gram to 100 gram X. Of course, X is larger than 1800 units, and then the size of electron cloud as well as an atom will be 10 gram to 100 gram X. Now, after the tricky part, it's time for something straightforward. Regarding the number of charges, an electron carries -1, just as it shows here. So, the electron cloud carries -1 times number of electrons. Neutrons, like their names, carries 0 charges, and each proton carries +1. Then, for a nucleus, it carries +1 times number of electrons. And for an atom, it carries 0 net charges because the positive and negative cancel out. One more thing to point out. There is one cloud of electron and one nucleus within an atom. Since a nucleus contributes almost 100% mass but 0% size to an atom, it is rather dense. That means most size and volume comes from electron cloud. Thus, we can say most volume within an atom is almost empty space containing a few electrons only. Here in this picture, although the nucleus and the atom are not to scale, but it still shows us the spacious volume within an atom. All good after the learning part. Now let me test your understanding with 3 questions. Question 1 is, how many times smaller is a nucleus than its corresponding atom? How about mass? It is a basic question testing your memory, and if you can recall P versus soccer court, you will come up with the answer, 10 gram to 100 gram times. By the way, a P is at 1 centimeter level, while a soccer court is at 100 meter level. But the nucleus contributes 99.97% to an atom's mass, because electrons are extremely light. Cool. Now question 2 asks, for an oxygen atom given its proton number as 8, then how many electrons does it have? In order to answer it, let's recall how many charges each particle can carry. For proton, it is positive 1, and for neutron, it is 0. An electron carries negative 1. Because we're talking about an atom, it must be electrically neutral. So the number of protons must be equal to that of electrons, which tells us in this case there are 8 electrons within an oxygen atom. The third question for today is, what interaction exists between electrons and nucleus? Here we have a hint. Think about what charges do electrons carry, and how about a nucleus? So, the answer is electrostatic attraction. It pulls electrons towards the nucleus so they won't be lost, maintaining 0 net charge for atoms. All good, flashback time. Today we unlock section 1.3, introducing cloud of electrons, nucleus, protons, and neutrons. More importantly, we concluded the size, mass, and charge comparisons of these particles. If you have not done so, please leave your comments now to help me make this channel better. Also, please feel free to leave your questions and I will help as soon as I can. Don't forget to like this video and share it. More importantly, please subscribe my channel and turn on the notification so you can watch my video first time. Today we level up to level 4, and we will be looking into atom classification in our next lecture. I'll see you around.